right? So again, finding k is just one step along the way. That's my answer, the equation, which I'm going to ask you for. And then I need to find what is y when x is 5,000. So put in 5,000 in for x, and that's the last answer. These are the two answers I'm looking for. What is the equation that describes this relationship? And then what answers the question? The other one we looked at was direct. Right, so this was the problem we had last class, the example we did last class, which I did already, but I'll review it again. And how do you know it's direct? How do I know it's directly proportional?
It says direct.
It says direct. Everybody see that? So that means right away I say, oh, that means I have y equals k times x. All right, so then I need to figure out what my y should be. So I'll find the what, or the how. So what are the two things that vary here? Two things that vary?
Cost in units.
Cost in units. The what, that's my y. So I'm going to make cost my y. I'll make units my x. So here I'm going to have 15 comma y. I have to find that. The other one is, let's see, cost is my y. So 550 is my y. 8 units is my x. So here I have 8 comma 550. So those are my 2 points. All right, so then I said that I'm going to plug those. If you want to do the simplified thing where I said k is equal to y over x, so that's equal to 550 over x. Is that easier, or is it easier to just plug it into the formula? I'm good with either one. You can do it that way, and you'll get, what do we get for that one?
68.75.
68.75? Or you can plug it into the regular equation. So I have 550 equals k times 8, divide both sides by 8, and you get k equals 68.75. I kind of almost think this is better, because I don't want people to think that that's the formula that you should be using, or that's not the formula. So again, that's not my answer. My answer would be then putting this into my y equals kx formula. So 68.75 x. This is important. If I asked you for an equation that describes the situation, that means y equals something with x in it. Y equals 3x plus 4. Y equals x squared minus 6x plus 2. Y equals something with x in it, and everything else is numbers. My variables, the things that change, are y and x. Everything else should be numbers. So this is what we mean. We don't mean we don't mean k equals. We want to mean y equals something with x in it. This is the equation we're looking for. Good? So then we need to figure out what is y when x is 15. So y equals 68.75, and when x is 15, put 15 in for x. And I don't remember what we got. What did we get?
1031.75.
Yeah.
Good. That's the second answer. Okay, so now you folks have got 2 to do. A bunch to do. Actually, you have this one. So again, I want you to give me y equals something with x in it. Figure out whether it's direct or inverse. This one, and then 2. This one we're only asking you to find the k. So here, this is a little bit easier. They're only asking you to find k. It's a little bit less work. There isn't other things to do. And then 3 and 4. Yep, pretty straightforward. Okay, so first thing you want to look at is figure out whether it's direct or inverse. And you got to read to find that, right? You got to look at it and read it. And that will tell you which equation to use. Remember, if it's direct, you're going to use y equals kx. If it's inverse, you're going to use y equals k over x. Then you need to find your 2 points. One, you're given a point, and the one is the one you're trying to find. And again, I would recommend you make your y your how many or what is or whatever. And then you take the point where you have both your numbers, plug that into here to figure out what your k is, and then you have your equation. Okay, so we'll work on this the next 15 minutes maybe. So now we're working on a new one, exponentials. So exponentials have this form of y equals either a plus bx. You'll see 2 different forms. It will either be y equals c times a to the x, or y equals a times b to the x. They're the same thing. Your homework might call there's a number in front, and there's another number that's being raised to the x power. So that's the key parts of this, is that you have y equals some number being multiplied by another number that's being raised to the x power. I'm going to try to keep it as y equals c times a to the x, but you may see that other one, y equals a times b to the x as well. Just realize that it's the same formula. Just as a second ago, if you folks remember, y equals mx plus b, right? Mm-hmm. You all know that as a linear one. Y equals kx is really the same formula. It's just that b is 0, right? And m is, we're calling mk. That's all. It's the same formula. Linear. Okay. And then the other one we had a second ago was the inverse. This is direct. This is where we're on it. Inverse variation was y equals k over x, right? That's just a warp of y equals 1 over x that we've been working with, only now we're putting a number in for k. So this is not 1. Or it's the same thing, only it's just not 1. You know, it could be 1, but it could be any number, right? So it's not restricted to being just 1. Okay. Okay. So here, this is again an exponential, and what you'll notice is over here up to the side, it goes on and on forever and doesn't quite touch 0. And then here it kind of crosses the point and then goes up. We're going to explore that a little bit more. First of all, what's the domain of this function? I'm going to try to make it smaller if I can. What's the domain of this? So let me write the function for you again. Y equals c, and I'll maybe put parentheses around this because that'll make it a little bit easier for folks if I put parentheses around the a to the x. I feel like that helps clarify things for people. So what are the two things you can never ever do? The first thing you can never do is what?
Divided by 0.
Divide by 0. Do I have x in the denominator here anywhere? Am I divided by x in any way? No, okay. What's the other thing we can never ever do?
Square root of a negative number.
Square root of a negative number. Is x in a square root here anywhere? No. So, domain of this is all real numbers. Good.
Negative infinity, positive infinity.
Yep, all real numbers, negative infinity to positive infinity. What's its range? Aha, the range is a little bit different. So if you look at it, it sort of starts off here, goes up, and then kind of goes up really steep like that. What's the lowest it goes?
0, but not equal to 0, right?
Here's 0 but not equal to 0.
Yeah.
Can anyone see that? It goes down so it's really close to 0 but doesn't equal 0. Can you see it from the picture? So 0 but does not equal 0. So it's going to be a rounded bracket there, right?
Mhm.
What's the highest it goes?
Yeah.
Positive infinity.
Positive infinity, and we can never touch infinity, so that will also be a rounded bracket. What intercepts does it have? In particular, what's the y-intercept? So here's the y-intercept right here. And that happens, let's see, when x is 0.
0, 1.
Almost. Yeah, it is 0, 1. In this case, it's 0, 1. Yep. In general, it's 0, comma b. B is my y-intercept. What asymptotes does it have? Do you see any asymptotes here where it gets closer and closer to the line but doesn't touch it? What's my dotted line that gets closer and closer to and doesn't touch?
0.
This one right here?
Mhm.
Can folks see that? All right, what's the equation for that? What's 0? Is it my x always 0 or is my y always 0 as I go along here? What's this point?
Y equals 0.
What's this point right there? And what's this point? Pick 2 points. I would find what this point is. Should I do it in blue? What's that point?
0, 1.
What's this point? 0, 1 or 1, 0?
1, 0.
Oh, 1, 0.
1, 0. What's this point here? 1, 2, 3, 5, 0. So what stays at 0, x or y?
1.
Y. Does everyone understand that? So it's going to be y equals 0. Good? If you're not sure, like I said, pick a couple points and figure out which one stays the same. The one that stays the same is y. What does y equal? 0. That's the easiest way of sorting that out. The base has to be a positive number and cannot be 1. That means it's either a fraction between 0 and 1 or a number greater than 1. So this, let me go back here. This is what we call the base. So the base is the thing at the bottom, and the exponent is the thing that's kind of up on top. Does that sort of make sense? So you have the base, which is, you can think of the base of anything. It's always solidly on the bottom, right? Base is on the bottom. The exponent is the thing it's kind of being raised up to. So the base is a, the exponent is x. All right, so let's see. We're going to work through a few of these. So I would like everybody here to complete this table. So you're going to do 1/2 raised to the negative 3. So do it on your calculator. Try to figure out how to do it on your calculator. I'll do it on my calculator. How's it sound? You all see that okay? So I'm going to do 1/2. So I'll do parentheses, 1/2, 1 divided by 2, in parentheses. And then I want to raise it to the negative 3 power. So I'm going to raise it to the negative 3. That's how mine works. And I'll get 8. So fiddle with your calculator. Take 1/2, raise it to the negative 3 power until you figure out how to do it to get 8. That's what I would say.
What do you do, 1/2?
1 divided by 2 in parentheses, that's 1/2.
Yeah, right. How do you put the slash? Oh, you just
Divided
put
by, divided by.
Oh,
It puts a slash for you.
okay.
Yeah.
2, and then parentheses.
Or if you want, you can either do 1/2 first. I could do 1/2, 1 divided by 2, enter, and then raise that to the negative 3. And just remember that 1/2 is 0.5, and I can use 0.5 for 1/2 from here on out. I can just do, 0.5 raised to the negative 3.
Oh, and then you just hit this x negative 1 button, and then you put 3? Is that the one you hit?
Maybe.
Mine has like an x negative 1, so you have an x2 and then an x negative 1.
And then change it to 3. No, I think you have to do negative 3. Oops. X to the y, probably. Do you see an x to the y?
I just see this x to the 2, x to the
Oh, here it is. Raised to the negative 3. That's
y.
easy.
Oh, that thing? Oh,
Yeah.
okay.
So if you have a fancy calculator, here, give me your calculator for a second. I'll show people.
Oh.
So you have these nice TI 30 calculators. These are great. Love these. So this one, yeah, I can see stuff. There we go.
Oh, there.
Here. You do 0.5, and then you do the raise to. Is this little arrow up button here? That one right there. So I just do arrow up, and then the negative sign is this. To get a negative, you can't do the minus. You do this one in parentheses that tells you it's down here at the very bottom.
Yeah, I finally found that.
Yeah.
I was trying to do the
Right. So
minus.
this here, oops. This here is how you get a negative sign on these TI 30s. It's actually the equal sign. So I want raised to the negative 3. Bam. 8. Yeah, those are great. Love these. Okay. So is everyone solving the rest of these? So do them all. If you kind of look at it, you'll say, oh, look, all my y's are positive. So I don't need to have, my y's can start, like this could be my y-axis here. My axes, like that. And then, let's see, when x is negative 3, it's at 1/2. It's at 8. When x is negative 3, it's at 8.
So 2 times.
So up here, when x is negative 2, it's at 4. When x is negative 1, it's at 2. When x is 0, it's at 1. Then 1/2, 1/4, 1/8. So it looks to me like it's going kind of like this and kind of off
Yeah.
like that. Is that what everyone else is getting? Okay, good. What's the domain? Yeah. What's the domain? What can x be?
All real numbers.
All real numbers. Negative infinity, positive infinity. State the range. What can y be? What's the lowest y can be?
0, but not 0.
0 but not touching it, yeah. 0 but not 0. Yep. And then what's the highest y can be, Deja?
Positive infinity.
Great. Positive infinity, perfect. Identify any asymptotes. So here's my asymptote here. Right along there. What is that? Something equals 0. What equals 0? X or y? What's always 0 along there?
Y.
Y. Y equals 0. Good. Okay, let's take a look at the next one. Now it's 2 to the negative x. So everybody work on doing these ones. It should go a bit quicker. And again, I would graph it like, I would do my graph along here and along there, since I know that my y's are only going to be positive.
Oh, your Y's are on the
Yeah. My y's are always end up